Hello everyone, welcome to Academy. I am Dr. Nandita and today in this video I will cover some typical numerical problems on the concepts that we have learned on the chapter solutions. So let's get started. So here in this problem has been taken from JJE Advanced Examination 2022 and the problem is asking an aqueous solution is prepared by dissolving 0.1 mole of an ionic salt in 1.8 kilogram of water at 35 degree C. The salt remains 90% dissociated in the solution. The vapor pressure of the solution is 59.724 millimeter of Hg. Vapor pressure of water at 35 degree C is 60 millimeter of Hg. The number of ions present per formula unit of the ionic salt is that we have to calculate. So let's see what are the information that are given and what we need to calculate. So because this is an ionic salt, it will get dissociated in the solution and so let's select the white color. Yeah. So the concentration of the solute is given. Okay. So what can be considered is that one molecule of the solute, because it is dissociated, one molecule of the solute can give you I number of ions and the concentration of the solute is given as 0.1 mole and also the information is given that it will remain 90% dissociated. So how many moles will be dissociated then? 0.1 mole times 90 divided by 100, which is giving you 0.09 mole. Now if you can consider that 1 mole of solute is giving you I moles of ions, 0.09 moles of solute will give you 0.09 I mole of ions, right? So this is nothing but the number of moles of solute or N solute. Now let's write down the expression for the vapor pressure of solution, which is already given. So this is the mole fraction of solvent times the vapor pressure of solvent. So this mole fraction can be written as number N solvent divided by the number of moles of solute plus number of moles of solvent, that is the total number of moles of the solute in the solution times P solvent, right? So this is your vapor pressure of solutions expression. So now if you number this equation as equation 1, so let's see what are the values that are given. So vapor pressure of solution is given as 59.724 and your N solvent, that is the number of moles of solvent, can be calculated using the weight of the solvent, that is 1.8 kg times 10 cube divided by the molar mass of water. So number of moles of the solvent is equal to the weight of the solvent divided by the molar mass of the solvent, that is 1.8 kg times 10 cube divided by 18. And now in solute has come out as 0.09 I plus in solvent. Now if you calculate this part, it will come out as 10 square. So I will directly write here the value of 10 square. And the vapor pressure of the solvent is also given as 60 millimeter of Hg. So times 60. Right? From here, if you calculate the Van der factor, the number of or I, it will come out as 5.1, or which is approximately equal to 5. So that has been asked to calculate here. So the number of ions that we were considering in the beginning, that one molecule or one mole is giving you I number of ions. So I has been calculated as 5. So the answer will be 5. That is the number of ions which is present per formula unit of the salt is 5. Simple. You need to only consider this formula where the vapor pressure of the solution, mole fraction and are connected here. So that's the way you should solve this kind of problem. Very simple. Now let's move on to the next one, where it is asking that CO2 gas is bubbled through water during a soft drink manufacturing process at 298 Kelvin. If CO2 exerts a partial pressure of 0.835 bar, then X millimole of CO2 would dissolve in 0.9 liter of water. The value of X here we have to calculate. Some informations are also given, which are Henry's law constant for CO2 at 298 Kelvin is 1.67 times 10 cube bar. So now let's see how can we solve this problem. So Henry's constant is given as 1.67 times 10 cube bar, right? So what we know that the pressure of CO2 is equal to the mole fraction of CO2 times the Henry's constant, which can be expressed, maybe I can write it as KH. This is our Henry's constant. So this is the pressure of carbon dioxide. This is the mole fraction of carbon dioxide, right? And this is our Henry's constant. So if you check, you can see that two of the values are given. So from here, X CO2, that is the mole fraction of CO2, has come out as PCO2 divided by KH, and PCO2 is given as 0.835 bar, and your Henry's constant is given as 1.67 times 10 cube bar. Now if you calculate, it will come out as 0.5 times 10 to the power minus 3 as your XCO2, that is the mole fraction of CO2 is 0.5 times 10 to the power minus 3, right? And now your XCO2 can be written in the following way. number of moles of CO2 divided by the number of moles of CO2 plus number of moles of H2O. Total number of moles in the solution is equal to 0.5 times 10 to the power minus 3. Number of moles of CO2. Now let's first calculate the number of moles of water first. So here 0.9 liter of water is given. So the volume is given. Volume of water is 0.9 liter or 900 ml. And the density, you know, density of water is 1 gram per liter or gram per ml. So from here you can easily solve the mass of water. Which is the volume of water times the density of water, which is giving you 900 gram. This is the mass of water. Now if you want to calculate the NH2O, that is the number of moles of water, you can easily do that because you already know the mass of water, which is 900 grams. So number of or NH2 I want to calculate from here, which is giving you the 900 gram, which is the weight of the water or solvent, divided by the molar mass, which you already know, 18 for water, and this is giving you 50 moles. If you calculate, you will get 50 moles, right? So your NH2O has come out as 50 moles. Now from here you can easily comment that since number of moles of CO2 is much less than number of moles of H2O, so what can we say? That NCO2 plus NH2O is approximately equal to NH2O. So from this expression then what can we get? NCO2, and this is nothing but your NH2O is equal to 0.5 times 10 to the power minus 3. So number of moles of CO2 is equal to NH2O, which is nothing but, we have already calculated, NCO2 is equal to, NH2O will go in this way, and so we have already calculated this as 50 moles times 0.5 times 10 to the power minus 3, which is giving you 25 times 10 to the power minus 3. So this is the number of moles of carbon dioxide which they have asked to calculate, but we have to convert it in millimole. So this is, if you make a star here, and I'll solve the rest here. So NCO2 is giving you 50 times, we have already calculated, so we can directly put the value as 25 times 10 to the power minus 3 times 1000, right? So if you calculate, you will get 25. So this is your NCO2 in millimoles. So 25 millimoles is the answer of this question. So your X is in millimole is 25. So I hope you have understood and you have enjoyed this video. For more such videos, keep visiting Abdemi. Thank you very much. Have a great day. Thank you.